Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to learn about the sine and cosine laws. So today we're going to learn about the sine law and the cosine law. We're going to verify that they are true using an investigation that involves technology. And we're going to also figure out when is the best time to use the sine law and when's the best time to use the cosine law to calculate the sides or the angles of triangles, not even right triangles, but any acute triangle. To start off, let's actually look at a right triangle. O'Neill says that he wants to label the sides of the triangle so that he doesn't have to say these words like hypotenuse, adjacent, opposite. They're just too many syllables. It's too long to say them. In triangle ABC, what letters would you use to describe each side? Pause the video here and come up with three letters, one for each side. Well, in math, we're pretty lazy. We don't. Not only do we not like to use too many syllables, we also don't like to memorize things too much. So instead, we say, okay, well, if this is angle A, it's touching this side, it's touching this side. Ooh, it's not touching this side. So why don't I say that this side is side A? And that way, I'll always know that an angle is opposite the same side. They will have the same letter, but for the angles, maybe I'll use just capital letters. And for the side length, I can use the same letter, but lowercase. And very similarly, angle B would be across from side B. And the hypotenuse in this case would be C, because it's across from the 90-degree angle, which we labeled angle C. And this is a general case for triangles. In triangles, we try to use the same letter for an angle and its opposite side. The angles are capitalized, whereas the side lengths are just lowercase. In this investigation, and I'll invite you to pause here and go ahead and scan this link to go open up Desmos's Triangle Creation e-tool. And you're going to use that to fill out this chart below. The e-tool will give you 1, 2, 3, 4, all 6 of these values, 3 side lengths, and the 3 angles. And it's up to you to find out what value goes in here by taking the side length, A, and dividing it by sine of angle A. Same with this column, and same with this expression right here. Plug in the values A, B, and the angle C, and evaluate this entire expression and put the the resulting number right over here. Pause the video here and take as much time as you need to go ahead and do that. Well, when I made my first triangle, it sort of looks something like this. Okay, you can see that in this case, the side length A was about 1.57, the side length B was 1.91, and the side length C was about 1.54. Angle A was 53 degrees. Angle B, which is right over here, was 76 degrees. And angle C, which is over here, is 51 degrees. And if I wanted to take 1.57 divided by sine 53, I get 1.97. If I take 1.91 and divide that by sine 76, I get 1.97. And if I take C, which is 1.54, and divide that by sine of angle C, 51 degrees, so 1.54 divided by sine 51 is actually 1.98. Finally, if I take 1.57 squared plus 1.91 squared minus 2 times 1.57 times 1.91 times cosine of 51 degrees, and I square root all of that, I get 1.53. In my next triangle, I did something very similar. I just moved the vertices of the triangle around, and I did the same thing, filling out the entire row exactly the same way that I filled out the first one. Now, I'm not going to go ahead and do 3 and 4 myself, but hopefully you were able to do those, and maybe you noticed something. Pause the video here and take a look at your chart, see if you notice anything. Well, on my chart, I'm noticing that these three numbers are really, really close. And in my second row, these three numbers were really close as well. I also noticed that this number here was really close to this number over here. And in my second row, not only were these three very close, but 3.09 was exactly the same as 3.09 over here. And what we've done here is verified two laws. We know that we verified that if I take A and divide it by sine of angle A, I get a certain number. And that number will probably be the exact same number that I get if I do the same thing with B or with C. And we can see that that's sort of true over here as well. The only reason why these might be a little bit off is because I rounded my numbers a little bit here, which I probably shouldn't have done. Over here, this expression ended up being the exact same as the side length of C, which is over here. And that was also true in the second triangle that I made. So these two are actually called the sine and cosine laws because we use the sine ratio over here and we use the cosine ratio here. The sine law is as follows. A over sine A equals B over sine B equals C over sine C. Or you could flip them all upside down and it would still be true as well. The best time to use the sine law is, of course, let's ignore this one for a second and just focus on these two because we have an equation here. The only way we can solve an equation is if we only have one unknown variable. That means that we need to know three of the others. And it doesn't really matter which three. No matter which three you pick, you always need a side and the angle that is opposite it. I try to call that a pair. A side and its opposite angle. If you have that and you have one more angle or one more side, that's when you can use the sine law. So if this is B and B, if those are the ones I have a pair. And that's when I use the sine law. The cosine law has two versions. This is the version where there is a side length isolated. And this is the version where it has an angle isolated. So it depends if I'm looking for a side length or if I'm looking for an angle. The time to use the cosine law is when you have three sides, A, B, and C, and then you can use those to calculate one of the angles. Or if you have two sides, A and B, and the angle that is in between them, the angle that is contained in between them, just sort of like this. Now, one thing to note about the cosine law is the angle that you choose here has to be opposite the side that is over here. These two, it doesn't really matter which order they're in, as long as these are the same. And similarly over here, this side has to match or has to be the side that is opposite this angle. Let's see some of these in action. Let's solve this triangle to the nearest millionth. And solve means to find all the angles and all the side lengths. Right now we're missing this angle and we're missing this side. The angle is really easy to find. I know that all of these three must add up to 180, so that would make this 113 degrees. Now, to find this side length, notice that I have x, which is an angle, and I have the lowercase x, which is 5. That's the side length. That is a pair. And using this, I could also, if I wanted, now that I found this angle is 113, I also have a pair right here. And whenever I have a pair, the best thing to do is to use the sine law. And I can use that to find lowercase z, which is the side length. To do that, I'm going to use a version of the sine law that has the side length in the numerator and the angle in the denominator. And I'm going to do that because it makes it really easy to isolate the side length. Now, I chose x over sine x, but I could have chosen, like I said, y over sine y. I have that pair too. And it wouldn't matter at all because like we saw in the investigation, this would actually end up being the same as y over sine y. So let's plug in my variables. I know that angle z is 40, x is 5, and angle x is 27 degrees. If I multiply both sides by sine 40, that will cancel out. And then 5 times sine 40 divided by sine 27 will give me the value of z, the side length. And that's 7.07. And if I want to round that to the nearest millionth, that's 6 decimal places. So I'll just round this up to a 7. There we go. That's how to use the sine law. In triangle PQR, which I'm going to start drawing right now, right? So that's a triangle. I'm going to label the endpoints P, Q, and R. Side P is 15 centimeters. So side P would be this one. That's 15 centimeters. Side R is 19. So that would be this one right here. And angle Q, which is this one over here, is 50 degrees. Now, in this case, if I want to find out the length of side Q, what I need, in this case, I would have, because I have two sides and I have the angle that is contained in between them, that tells me that cosine law is the right one to use. Okay, that will help me find the value of Q. So this is the cosine law. And if I'm changing these around, this is the side length that is unknown. That'll be Q. That means that this has to be P and this has to be R. I'll just write that down here. So that's P, which is 15. That's R, which is 19. The angle that is contained in between them is 50 degrees. And if I evaluate all of this by putting it into my calculator all at once, I'll find out that the length of Q is about 15 centimeters, 14.819 with some more decimals after that. In this case, I'm trying to find the measure of angle A. Now, although it looks like it, this is not necessarily a right angle triangle. Okay, and I can't assume that it is. All I know is that I have three sides and I'm trying to find this angle. And so if I have three sides, that's the time to use cosine law. This is the version of cosine law that has the angle already isolated. So if I wanted to change this around to match this triangle, the angle that should be isolated is actually A. And so that has to match this value right here. So this one has to be A squared minus B squared minus C squared all over negative 2BC. Now remember, if I put all of this into my calculator all at once, so I put 4 squared minus 7 squared minus 6 squared, all of that divided by negative 2, negative 2 times 7 times 6. And then once I get that answer, do the cosine inverse of it to find out that angle A is about 34.8 degrees. That's to the nearest 10th. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.